Hi everyone, today I'm going to show you how to take a molecule and represent it in 3 different ways. So the first way you can represent a molecule is an expanded structure. So what this means is that we will draw every single atom and every bond. Here, hydrogens will also be shown explicitly and who they're bonded to. And it is the most detailed way to show a molecule. Also most time consuming. So let's take an example. Let's say I have the structure of ethane, which is C2H6. Let's go ahead and make an expanded structure. I have 2 carbons. Attached are 6 hydrogens. To complete an octet, this hydrogen, I don't know why I'm keep on saying hydrogen. This carbon requires 4 bonds to make a complete octet. So here are my 3 hydrogens. Let's make sure and count if this carbon 1 has a complete octet. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Now let's do the same for this carbon and attach 3 additional hydrogens. Let's count and make sure it also has a complete octet. 1, 2, 3, 4. Oops, sorry. 1, 2, 3, 4, 5, 6, 7, 8. That also has a complete octet. Now, this is an expanded structure whereby I drew all of my hydrogens, no shorthand notation, and all of my carbons, also no shorthand notation. Now let's look at the second way I can draw a structure. So the first one was expanded. Now the second one is called condensed structure. A condensed structure, it means that instead of drawing every single bond, we will shorthand notate them. So instead of drawing each hydrogen bond, we will group them. We will group hydrogens to the atom they're attached to. Condensed structure is what it means. It condenses the structure. How it condenses is also we will use parentheses. We will use parentheses if the same group is repeated. Okay, let's also take the same example of ethane, which was, if you recall, C2H6. How do we write a condensed structure for ethane? Well, it is simply CH3 because it was bonded to 3 hydrogens, CH3, and then we continue and write the other carbon as CH3, as noted right there. Now I'm going to show you how the parentheses work and how they are grouped together, because this condensed structure is really short. Let's take another example and let's do this other example to showcase how condensed structure is used parentheses is if we use, I'll draw the expanded structure and then I'll show you what the condensed structure is. So let's say I have an expanded structure of 3 hydrogens connected to 1 carbon, and then this carbon is attached to another carbon, and that has 2 hydrogens. I have a carbon that's attached to an OH, another H, a CH3. Now, we will use parentheses to use around this atom right here. So how will that look like the condensed structure? Because this was the expanded, will look like this. CH3, CH2, CH, parentheses, OH, and lastly CH3. If this structure here, let's say I have a CH3, I'm also drawing again the expanded structure, had the same CH2s. If you notice here, they're all the same. And let's go ahead and continue. COH, HCH3. What the parentheses can be used is to condense this. So we can say CH3, because that's what the CH3, CH2, parentheses 1, 2, 3, a subscript of 3. Again, we can do CH, because that's what this molecule is, CH, parentheses OH, and a CH3. This is my condensed structure. Now lastly, we've looked at condensed structure as being one option, and we looked at expanded structure as being another option to represent molecules. The last one we will look at is something called skeletal structures. And skeletal structures is the one that you will commonly see organic chemistry use. So instead of drawing all of those carbon, 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 or even hydrogens, we will only draw the carbons. Let me erase that. So for skeletal structures, we only draw carbon-carbon bonds as lines, no hydrogens, although they are implied. However, atoms besides carbon or hydrogen, such as like oxygen, nitrogen, or chlorine, are written in. The only thing that's implicit are hydrogens. So let's take our beautiful example of ethane, which is C2H6. How we would draw that is one line that would show one carbon and another carbon. Actually, it would be straight, sorry. Actually, let's do ethane first, and then I'll show you more examples. So it would just simply be one line. Why would it be implicit? Well, imagine there's a carbon on each butt end, and to each carbon has implicit hydrogens, 3 hydrogens. So let's show you another example. So that would just simply be, that's not actually a very good example, but let's show another example. Let's do propane, which would be C3H12. I think that's H8. Okay, so let me first draw what propane is, and then I'll explain why I drew this. So for each end, whether each sharp end, so the end of this, the end of this, and the end of this, is implied a carbon. So imagine an imaginary carbon and another imaginary carbon and another imaginary carbon. So it being sharp-ended like that, I know that means there was 1 carbon, 2 carbon, 3 carbons, which matches perfectly the 3 carbons And then implicit are the hydrogens, which to this end required 3 hydrogens. Over here can only make 2 hydrogens, and the butt end of this carbon can only make 3. If I count them all up together, 1, 2, 3, 4, 5, 6, 7, 8, it matches the C3H8. Another example is butane. Let's take butane, which is C4H9. So if you look at butane, it has 3 carbons. I'm so sorry, I put H9, I meant H10. Butane has 4 carbons, so let's draw 1, 2, 3, 4. That now shows and implies 3 carbons. A carbon here, a carbon here, a carbon here, and a carbon here. Implicit are the hydrogens that I haven't drawn out yet. But if I were to, that would be 3 hydrogens here, 2 hydrogens here, 2 hydrogens here, and 3 hydrogens here. That's how we draw our skeletal structure. 1, 2, 3, 4 for 4 carbons. Now let's do some examples together so we get a better understanding as to how to make our expanded, condensed, and skeletal structures. Okay, let's do the first one, which is I'll put them into 3 categories: expanded, condensed, and skeletal. Oops, skeletal. Okay, that's our structure right here, C4H9Br. Let's create the expanded version, this expanded structure. Carbon has 4. It is connected to a Br, a bromine, and let's add 9 hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, expanded structures show everything. They show the bromine, they show the hydrogen, and they show the chlorine. Now let's do the condensed structure, which would simply be, if we take this right here, that would be CH3. If we highlight this structure right here, that would be CH2. If we take this structure right here, it's also CH2. Usually, if it's 3 or more CH2s, it would be easier just to simply, let's just say we had 4 CH2s. Then you can shorthand abbreviate like that. But since it's only 2, you can write it out like I have done. And then, oh, there are 3 CHs. So what I plan to do, because they're all the same, CH2, 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 I'm simply just going to write it as parentheses 3 to make it quicker. All right, and then lastly, we have a Br. Let's draw its skeletal structure. Remember, each pointy end counts as 1 carbon. So 1 carbon, 2 carbon, 3 carbon, 4 carbon, and then remember, BRs have to be written. Everything besides hydrogen have to be notated. And then at the end is my bromine. Okay, here are some more examples I'd love for you guys to try out, and then afterwards we can go through them together. So I'll just draw out an expanded structure, and you can fill out the condensed and skeletal, and then I'll just rearrange them. So maybe I'll draw condensed and then you'll draw skeletal and expanded, and or either or. So for this example, I'd love for you guys to try out. I'll draw the skeletal structure, and you can go ahead and fill in a condensed and an expanded one. And then for the second one, I'll draw the condensed structure, and you can draw out the expanded, and you can draw out the skeletal. And then for the last one, I'll draw out an expanded version. So I'll do CH. Okay, and I'll just draw that. And then once you're done, then we can do it together. Okay, let's go ahead and let's complete the condensed structure and the expanded structure of this skeletal structure right here. Okay, let's begin with the condensed or expanded, doesn't matter, but let's do the condensed. So over here, I see here it's a CH3. Over here is a CH. It is bonded to, remember, if it's something bonded to or has a substituent, we draw parentheses and we draw what it's attached to, which is a CH3. Then over here, it is a CH2. And lastly, on the end, it is a CH3. So my complete condensed structure is CH3, CH, CH3, CH2, CH3. And a way maybe it might make it easier to see is I will highlight which each carbon represents. So then this CH will represent this CH. This carbon at the sharp end represents, represents this carbon. This C from the CH2 represents this carbon. And lastly, on the end, let's change the color to peach, will represent this carbon right here. Okay, let's draw its expanded structure. So I need a CH3. I need a carbon that's bounded to 3 hydrogens. I need a CH bonded to a CH3. Then I need a CH2, and I need a CH3. Again, I'll highlight which carbon it represents. Oops, wrong color, sorry. Which carbon it represents. So this carbon represents this carbon, which represents this carbon. This pink represents this carbon, which represents this carbon. This red, which represents this carbon, which represents this carbon. This green, which represents this carbon, which represents this carbon. And lastly, the peach, this carbon, which represents this carbon, which represents this carbon. Okay, now let's draw the expanded structure of the second example, which is a carbon that's bounded to 3 hydrogens. Oh, I'm so sorry. A CH2. So I need to draw 2 hydrogens bonded to this carbon. And it is bonded to this carbon right here. And it has an H with the second carbon. However, this is not a complete octet because it only has 3 bonds. So I need to add an additional bond to make it a complete octet, which would be 1, 2, 3, 4, 5, 6, 7, 8. Perfect, that's a complete octet. Then I have a CH bonded to another CH2. And lastly, it is bonded to an OH. Let's create now the skeletal structure. 1 carbon, 2 carbon, but it's double bonded, so I have to show that with an additional bond. And let's say hypothetically it was triple bonded, then I would show 3 bonds. but it is only C double bonded to C. Then for this carbon number 3, the hydrogens are implicit, so I do not have to draw anything, but I do have to draw the oxygen, which is bonded to the hydrogen. So that's my complete condensed structure. Skeletal structure. Now for the last example, let's go ahead and create the condensed structure. So this carbon over here is CH3 because it's a carbon bounded to 3 hydrogens. This carbon is bonded to 2 hydrogens, so I'll be writing CH2. And again, lastly, for the end piece, CH3, that is my complete condensed structure. Now I will be drawing the skeletal structure. There are 3 hydrogens, 1, 2, 3, no double, no triple bonds, no other atoms that don't include a hydrogen like oxygen, nitrogen, and chlorine. So I simply just draw 1, 2, 3 sharp ends. This is indicating the skeletal structure for this and this. All right, if you need any more help, there's lots of problems online, and I hope that this video was helpful enough to help you understand how to draw skeletal, expanded, and condensed structure. Bye.